Okay, let's see what an ideal voltmeter is. Let's say you have a circuit like this with a source of EMF and a resistor. And let's say you measure the potential difference between point A and B by putting the voltmeter, the red part of the voltmeter at A and the black part of the voltmeter at B. And of course you have to make sure that the red and black parts are connected in the correct terminals. So this circuit has a current going through it, current I going through the resistor. An ideal voltmeter means that there's no current, the voltmeter itself doesn't take any current. So the current going inside the voltmeter is zero for an ideal voltmeter. A real voltmeter does take some current. The current is not usually zero. That means the current going through the resistor is not exactly I, it's I minus the current going through the voltmeter. So we're not going to discuss this issue now, we're just going to consider ideal voltmeters. So if you take an ideal voltmeter and you put it across a battery, a 1.5 volt battery for instance, like this, what would the voltmeter read in this case? In this case the battery is not connected to any circuit, it's just hanging in empty space. And we want to ask the other question, what if you take the same thing exactly, but now you connect the battery in a circuit? And this is going to be considered as a real battery. A real battery is different than an ideal battery, and you measure the potential difference across it. Will you get the same value as you did before or not? You will not get the same value, and we'll see why you won't, because a real battery, we can model a real battery to be consisting of an ideal battery, a source of EMF, an ideal source of EMF, and a small internal resistance connected in series with it, small r. So this whole thing is what we can call a real battery. And this is the situation, what it would look like if it's not connected to a circuit. If this battery is not connected to a circuit, then you measure the potential difference between points A and B. What would you measure? What would this voltmeter measure? Well, since the battery is not connected to a circuit, there's no current flowing through the resistor, so there's no potential difference between E and B. There's no current going through here. So the voltmeter will just measure the value of the ideal EMF, source of EMF. It'll just read epsilon. But put the battery in a circuit, and now you have a current flowing through the circuit, and there's a current through the battery. And this model then, when you have a small internal resistance and there's a current going through the small internal resistance, now the voltmeter, what would it read? Would it read still epsilon, or would it read a different value? That's the question we want to ask in this part. So let's take our real battery that consists of an ideal source of EMF and an internal resistance, and the question we're trying to find out is what's the potential at A minus the potential at B? The potential difference across the battery. That's what you would measure if you put a voltmeter between points A and B. What would you get? A systematic way to get VA minus VB is to get VA minus VE first for the ideal source of EMF, and this is simply equal to epsilon because the plus side of the battery is at a higher potential than the minus side, and then VE minus VB, the potential at E minus the potential at B. Now remember, current goes from high potential to low potential, so point B is at a higher potential than point E, and so VE minus VB is a negative number, and so it's minus R. Now once I know those two things, how can you get VA minus VB? Well, if you add these two, you get VA minus VB, because you have here minus VE and you have VE. When you add these two quantities, you only get VA minus VB, which is what you want. So when you add the right hand side, you get epsilon minus IR. So the potential difference across the real battery is not equal to epsilon, it's equal to epsilon minus IR. We go back to the problem we showed before. If you put a voltmeter across the real battery between points A and B, you're going to measure epsilon minus IR, the ideal EMF value, source value, minus IR.